Hi everyone and welcome back to another episode of sound design for video games. Today we're going to be setting up an audio reflection system where essentially any sound that we want, it could be say for instance a gunshot, is going to emit sound and it's going to reflect off vertical obstructions similar to this and also similar to this. So anything that's like a vertical obstruction that has collision, our sound will basically reflect off that. Now to demonstrate this, what I'm going to do is I'm going to drive over to the left and you'll hear the reflection coming from the left, and then I'll drive over to the right and you'll hear the reflection coming from the right side. I do suggest you wear headphones or listen on a good set of speakers, because if you're listening on the phone it probably won't get the sound across very well. But I'll do that now, so I'll shut up for a minute and just take a listen to how this reflection sounds when we get close to these barriers. So you can hear it really clearly there. Another thing to note is I've set it up differently for the different camera angles we have. So this chase cam is going to be set up differently for this chase cam so that the reflection is happening in the correct position relative to the chase cam. So if I drive now, you'll hear the reflection happening. So that's another thing to note. The reflection actually needs to change where it's happening depending on where the camera is. I just want to take a quick moment here to go through the actual physics of what's happening. So you can see here I have this very simple graphic which is going to allow me to illustrate what is essentially happening and what are we going to be trying to imitate inside of Unreal Engine. So when you reflect audio off a surface, something to note is if we are moving closer to that reflected surface as the audio is being reflected off it, the sound waves which are hitting our ears from that reflection are being compressed, which means the oscillations are going to appear to be quicker, which then leads to a pitch shift upwards. So this is what's called a doppler shift. If we move close to this wall, the reflected sound is going to appear to be being pitch shifted upwards. Now, if we are moving away from this wall, you get the opposite thing. Those sound waves are now being expanded, so you get the opposite effect with the pitch shift is actually being stretched. It's going lower, essentially. So you get a similar thing with space. You may have heard the term redshifted. If a galaxy is very far away, to our eyes the light will appear to be red because it's moving away from us. That's a similar thing. If it was moving towards us, it would appear to be blue. So what you see happen with light is also what happens with sound, but what we're dealing with here is pitch shift. So this is something that we're going to be implementing in our system, that Doppler shift effect. So to imitate the effect we've just went through then, what we essentially need is a delay. Because what's going to happen is as the sound goes out and hits a surface, it's going to have a delay before it's reflected. And then by affecting how long that delay is, we can then create a pitch shift from that delay, which will closely match what you might hear in real life. Now to set up something like a delay, you need to set up a whole sort of chain of effects. So this is similar to what you might do in a DAW, where you have a whole chain of effects and you can save it as a preset. This is essentially what we're going to be setting up inside of Unreal Engine. So the first thing you need is actually a source bus. So if I go over to the audio and go over to source, you can find something called a source bus. I'm just going to leave that named a new source bus. And now once that is created, obviously you'll have it named correctly. You might have it named something like reflection system or something like that. Once that's selected, you can then go to the add components and you can see that new sound source bus is there ready to be added in to our components for our vehicle. I actually have my source buses already in here. This is one here and I have another one over here. Now once you've created your source bus and brought it into, in this case it's the wheeled vehicle pawn, but for you it might be like a player character. What you need to do is you need to go through this chain which will eventually lead to the delay effect. And then what we're going to then do is we're then going to send the engine audio into the source bus, which will then eventually lead to that delay effect. So let's set up that chain now. So what I'm going to do is I'm actually going to open this source bus from here. You can also do this from the content drawer, wherever this thing is located. And then what you then need to do, you need to go to source effect chain. And for you won't have one created yet, so you can create another one here called source effect preset chain. And this is essentially a chain where you're literally keeping a preset for a chain, essentially. So once you've created that, open that up. And then from here, you're going to go to presets. And then you're going to create a source effect preset. So if I open this up, and now here we have our simple delay. I'm just going to go back one just to make a little point here. When you create this source effect preset, it's going to then ask you in a new window, what type of preset do you want? Now for me, I've picked a simple delay simple. From there you can pick many different effects like a reverb or a compressor. But what we want is this, a simple delay. Now I've set up the delay like this, so I've got the speed of sound as 343 meters per second. I have the delay and dry amount set to 0, the wet amount set to 1, feedback 0, and I've got both delay based on distance and use distance override checked. So the reason we have just the wet signal coming out is because what we're going to be doing is we're going to be sending the engine sound into this source bus, which is then going to be relocated somewhere which is by some sort of obstruction which is vertical, and then the sound will then be delayed. So we're going to have the dry sound of the vehicle and then just the delayed sound coming from wherever it's being reflected from. So that's essentially why we've set this up like this, where it's just the wet signal. Just a really quick point that everything we just did for this source bus here on the left also needs to be done for the right separately. So you're going to need one preset chain for this and another preset chain for this, because later on when we are changing these delay values here, we're going to need to make sure that you can do this separately. You don't want the left side source bus affecting what the right side source bus is doing. So hopefully that makes sense. Now to move on, what I do want to talk about is the attenuation settings for this source bus. Now these are both the same for the left and the right, so I'm going to show you it for the left and you can just sort of copy that across. So the first thing we want to go to is attenuation. You can see I have allow spatialization on, I have override attenuation on, then on attenuation volume I have that unchecked because I want to be setting that volume myself, basically depending on how close we are to the surface. So I'm going to have full control over that. Then we have attenuation spatialization on, and we have it set to panning. And that's basically everything which I think is important for the attenuation settings. So take a look at how I've set that up, and you can essentially copy me and then change it for your purposes, essentially. The next thing we need to do is to actually tell Unreal Engine what we want to be sent to these reflection source buses. In my case, I want to send the car engine. So here's the car engine here. So with that component selected, where is it? Here it is. So with that component selected, there's a few ways we can send it to these source buses. So you can see here, I can send it to a source effect chain right here. Now the way I've done it is I've actually opened up the meta sound that's responsible for this car engine sound. And in the source settings here, you can go down, find source, and then I'm using a pre-effect bus send. And I know on 2, we are sending it to the left source bus. And then on index 3, we're sending it to the right source bus. So that's essentially important, so that you need to send it to the correct one. Okay, now that you've set up all of that, we're now ready to actually get into the blueprints and the logic of how we actually make this work. Now we're starting off with a custom event, which is being called at the event tick. This custom event, I've named it Sound Reflection System. and it's going into a sequence. Now, because we have two, a left source bus and a right source bus, we basically have exactly the same code coming out of this sequence with a few minor differences, which I'll go over at the end. So what I'm going to do is I'm going to just focus on is this the left side? Let me just check. Yes, this is the left. So I'm just going to focus on the left side of this stream of logic. And then essentially the right side of this stream of logic is exactly the same, other than a few minor changes, which I can essentially go through with you. So the first thing we're doing is we're going into a branch and we're asking, is front camera? So I want to know what camera we're using, because depending on what camera we're using, we're going to need to locate our source buses in a different position so that the reflection sounds right, if that makes sense. So what I have are these child actors which are inside of the components. So you can just click on this, and if you type in actor, you can add something called a child actor and name it. So if I actually go to my viewport, I'll just show you them now. So I've got it called a line trace, I believe it's called. Line trace left ear. So there it is. See this little dot here? So that is essentially my child actor. So it's nice to have that there because I can basically place this anywhere relative to the wheeled vehicle pawn. And then I can get that transform data quite easily from here, and I can then plot it in and set it correctly, essentially. So I've got one here for the left and one here for the right. And then these are being referenced here to essentially set the relative location based on what camera is being used. And then we're going to use these locations then later to set where essentially line traces are happening, which will then determine where the source buses are going to be relocated. So hopefully that all makes sense. So yeah, so we have this set up. Now for the right side, it's exactly the same, except obviously we're positioning it to the right of the vehicle. So you can see the location data will be very slightly different. So for instance, on this one, we have -76, where on this one we have +76. So that's one minor difference there. Then coming out of these set relative locations from these child actors, we are then going to set a float variable, which I've called line trace left ear length. Now we're setting this one to -750. We're setting the right one to +750. So there's another minor difference. What this is going to do is it's basically going to be a value which we're going to reference multiple times. And the reason we're doing it here is so that it's just consistent for the rest of the code. So say for instance, I just was setting these variables everywhere in the code. I could set it differently in one place and then have a problem, and then I'd have to go and find what that problem is. So we're setting it here early on just so that we can go and grab it, and then I can make that value consistent all the way through this stream. So that's why we're setting that as a variable, which we're going to then get later. So from here, we're then going into a line trace by channel. And the start of this line trace is based off the line trace left ear child actor. So it's based off these. And their location is being set based off the camera. So this is going to change where this line trace is happening based off the camera, essentially, if we're using front camera or the back camera. So to get the start, we are simply getting the world location and coming straight off that. To get the end results, we're doing a little bit more. We're getting the world location. We are adding to that all of this, essentially. So what we're doing is we're, again, getting the world location, getting the right vector, because essentially we want this line trace to go off to the side relative to our vehicle or relative to your character. We are multiplying that by oh my god, I forgot what this is called, a vector. Okay, we're multiplying this by a vector. This is where we're getting this value. So we're getting the line trace by left ear, and we're sending that into this vector, and then we're essentially adding that to the end. So what we're essentially saying is we want it to go minus 750, I believe it's centimeters, minus 750 centimeters to the right is essentially what we're saying here. Okay, so all this going into the end, we're basically saying minus 750 centimeters to the right. We're drawing that line trace. And we're doing the opposite here. This is plus 750. So this will be this one will actually be to the right, whereas this one, minus 750, will actually be to the left, because it's negative. So I can actually show you that now. If I draw the debug for a second, we'll say for duration, and we can actually demonstrate this working correctly. So I'm going to compile this. It might do a little bit of glitching. Compile. Yeah, there's an awful lot to compile. I'm now going to save it. So now when I press play, you can see this line actually being drawn. So I'll move over, and what I want to show you is that this line is being drawn in a different place depending on what camera we're using. So if I press shift, I go to the bonnet cam. Now if I quickly go to the back cam, you'll still see that line trace being drawn from a new location. So if I go this, you see that line trace is now being drawn from the front of the camera. Now why are we doing this? Why am I drawing the line trace differently depending on where the camera is? The reason is I want that reflection to come at a certain location so that it gives the player the best stereo experience. So if they're using chase cam, I want them to hear the reflection coming from this specific area. If they're using the bonnet cam, I kind of want it to be very, very wide stereo image. So I've placed the line traces basically right where the camera is. So you can see if I come out. So essentially that's going to give a nice wide stereo image. So that's why we place the line traces where we are. Now to continue on past the line trace by channel, what we're doing is we are setting a float variable which I've called line trace left ear distance. And this is being set from the out hit, break hit results and distance, and we're multiplying this by -1 to essentially get a positive value, because we are shooting this line trace out negatively, so we need to convert it to positive here. You could also just drag off this and get an absolute node, and that'll do exactly the same thing essentially coming into here. Now if I come down, you'll see on this line trace we have a different float variable which is for the right ear. So it's the same thing, it's just I've named one left ear and one right ear, and then we're getting those relative variables in each stream. So what we're then doing is we're going into a branch, and this branch is either going to be true or false based on the return value from the line trace. AKA we're asking, did the line trace even hit anything? If it does hit something, we want to do one thing. If it doesn't, we're going to do something else. So let's go through what happens if we do hit something. What happens if there is a surface to our left and this line trace has hit it? So what we're going to do is we're going to be setting the volume multiplier of that source bus that we added at the start. So this audio source bus, which we created at the start and added to the components, you can see I've called mine, very long name, audio source bus, delay left, comb filter. So I can actually look for that. I can see it right there, audio source bus, delay left, comb filter. I can go and get that. And that's where you'll drag off and you'll say set volume multiplier, basically. So that is our source bus. The set volume multiplier is simply going to be how loud is this source bus going to be. So I have this set to a map range clamped, and you can see that the line trace by left ear distance is going against the value, and the line trace left ear length is in range B. So we're saying from 0 to whatever this is. In this case, it's going to be positive however long this line trace distance is, basically. So the distance is the negative value being multiplied by -1, So it's going to be however long this distance is, which will be to a maximum of 750 basically. So that's essentially what that means. So what we're saying is at a distance of 0, aka we're very close to a wall, we are setting the volume to 1.2 here. But then if we are at a distance much further away, say 750, which is the maximum distance this can be, then we're going to be setting the volume to 0. So essentially what we're doing is we're setting the volume to be louder and quieter depending on how far this line trace is drawing. So, how close are we to the wall, essentially? If we're closer, we want it to be louder. If we're further away, we want it to be quieter. In this case, I've said silence, essentially. Then what I'm doing is I'm going into an interpreter constants, and we're taking the value of that with the target of 0, delta times 0, and I'm just setting the interp time to 0.2. So essentially 0.2 seconds, it's interpolating the values coming out of here and smoothing them out. So we don't get like very sudden changes, essentially. It's going to happen more smoothly. The volume is going to change in a smoother way. So what happens if we come out of false? We're doing exactly the same thing. So we come out of false, we're doing basically the same thing. Now what you might say is, and I was actually looking at this yesterday, I was like, why did I do all this? What you might think is, oh, well, we can just set this to 0, because if it's false and this line trace isn't hitting anything, then we just want to make that source bus 0 because we don't want to hear any reflected sound. The issue when you do that is that I'll actually go into the map to sort of demonstrate this. If you have little tiny gaps where essentially the line trace can go through, so let's say this was a tiny, you can actually see there a tiny little gap. If that gap doesn't have collision, what will happen is the line trace will go through it and it will immediately set that value to 0. And when it does it immediately, it sounds a bit weird to your ear, the fact that the reflection will just disappear so quickly. So what I want to do is I want to make that reflection disappearing basically sound out a lot more smoother. So that's what's happening here. It's exactly the same thing as this, except we've basically reversed these. So this is now 0 and this is now 1.2, and I'm giving it an interp speed of 0.6 seconds, so it's more smoother. So essentially when we're not wanting a reflected sound, we're smoothly setting that volume multiplier to 0 before it goes silent, so that we don't get any unwanted effects where the reflected sound is suddenly disappearing. So that's essentially why we've done it this way. Now coming out of this, we are setting the world location of this audio source bus, and you can see that is based off the location of the break hit results. So wherever this line trace is hitting, we're saying what is the location of where that line trace hits, and that is how we're setting the location of this source bus. So just to remind you, that is these here. So let's say we have our line trace coming out of the bonnet here. This is our left source bus, and let's say we have a surface here. It's going to pick up this surface and it's essentially going to relocate that source bus to that surface whilst the player is playing the game. So that's essentially what we're doing here. Then coming out of this is where we're actually setting up the delay effect for that source bus. So what we're doing is we are casting to source effect simple delay preset, which is this. This is our simple delay presets. But we've got to know, well, which one, because there may be many simple delay presets. This is where we're coming out and we're saying break sound effect chain, and then we're coming out of this, and then we're saying make source effect chain entry, and then we're selecting the specific one that we want to affect. So I've selected the delay left. For the delay left, if I come down here, you can see it'll say delay right. So that's how another little minor difference that's changed in the code there. So that's essentially what we're doing. We're getting a reference to this specific delay so that we can, not this one, sorry, this one, so that we can then affect some of its settings. So So coming out of this, we're then setting the settings. Then in settings, we are making sound effect simple delay settings. So you see now we have these amounts that we can change, and the one we're interested in is actually the delay amounts. And actually, come to think of it, now that I look at it, this delay based on distance and this use distance override are both unchecked here. So where I said, oh, I have these checked, it doesn't really matter. We're changing that here anyway. So just picked up on that just then looking at this. Now, this delay amount, one thing to know about delays is that when a delay is changed to be shorter, what essentially happens is it will actually pitch shift the sound up automatically. And when a delay is changed to be longer, it will actually automatically pitch shift that sound down. So this, the work we're doing here, is what's going to give us that Doppler shift effect that we're looking for, which is going to make it sound really nice and realistic. So the way we're doing that is with a map range clamped, and we're taking the line trace left ear distance, which again is just coming from this line trace. What is the distance that this line trace went before it hit something? And then we're taking the line trace left ear length, which is input B. So that's essentially the maximum length that the line trace is drawing against the distance that the line trace drew before it hit something, essentially. So we're saying from 0 to the maximum of the line trace left ear length, we're map ranging that to a delay amount of very, very short 0.001 seconds, and then 0.03 seconds, so 30 milliseconds. So essentially, depending on how far away we are from a wall, the delay amount may be 0.001 if we're very, very close. It's actually impossible because you'd have to be inside the wall, but if you're very, very close to that wall, you can get 0.001 on the delay effect. If you are further away, you might get up to 30 milliseconds if you actually get right away up to that 750 centimeter distance, essentially. And that's essentially the whole system. So let's take a quick moment and go through where the two might change, just in case you need any help with that. So I'll go through it from sort of the beginning. So obviously these references on the child actor are unique from the left ear to the right ear, so they have to be different. Basically any variable will have to be for the right ear, one will have to be for the left ear. You see these, right ear, left ear. This is all the same. Again, this is different, so the line trace left ear distance, here we have line trace right ear distance. So it's all the same except for the variables need different names, essentially. Yeah, right ears, and I think that's it. Oh, and yeah, here, so you see, I think I already went through this with you. You got to pick the delay left ear, and here you'll have to pick the delay right. Again, these variables are for the right ear, and that is basically all the differences between those two streams of data. So a good rule of thumb is any variable, you'll need another version of it for the other ear, the other side, if that makes sense. I like saying ear because I think of it as like the sound reflection being picked up from that ear, so that's why I say ear. But you know what I mean. You can set that to whatever you want. So basically that's the entire system. If you do have any questions or you need any help, please do let me know in the comments and I'll try my best to help you. Thanks very much for watching. I'll catch you next time.